Greetings to every one of you. In this video, we are going to discuss another very important concept from machine learning, that is SVM classifier. SVM stands for Support Vector Machine. It is one of the widely used supervised machine learning algorithm. It is used to solve classification and regression tasks. However, it is highly used for solving the classification problems, in which we should understand some of the important terms. Number one, hyperplane. SVM finds a best decision boundary is called a hyperplane that segregates a labeled data set into two classes. For example, let us consider this is one set of data, this is another set of data. The line which separates, straight line which separates, they are called as hyperplanes. Then in hyperplanes, we need to know about another important concept is called margin. Exact hyperplane can be selected by its margin only. Margin, it is a distance between the hyperplane and the closest points from both the set of data points. This is one set of data, this is another set of data, and these data sets are divided by a line. So this line classifies the data. So there is one side we have circles, on another side we have squares. Important note is that the hyperplane with the maximum margin is considered as the best one to classify the given set of data points. For example, this margin can be calculated or generated with the help of just extending or drawing the perpendicular lines from the closest data points to this hyperplane. See, for example, consider this is hyperplane 2, this is hyperplane 1. So the closest points to this hyperplane, it is this circle. So generate a perpendicular line to this closest data point. Similarly, as far as the square is concerned, this is the closest point, closest object near this hyperplane. Similarly, as far as this hyperplane 2 is concerned, this is the closest one, and similarly this is another closest one. If you compare these two, the best hyperplane is that the hyperplane with the maximum margin. So here the margin is larger, but whereas for hyperplane 2 it is very close. So that is the idea of margin. So margin with maximum distance, that is considered as the best margin, and that particular hyperplane is the best one which classifies the data exactly. Next concept is support vectors. Support vectors are the data points that lie very closest to the hyperplanes, and they are used to define the hyperplane. See, consider this diagram, this graph, in which we have two sets of data. So one side we have plus and another side we have minus. So if we generate this connecting all these closest points, see, for example, this is one point, so this is another point, another point. If you connect these 3 points, this is one particular, we have 3 points. These points are nothing but the support vectors. These points are the support vectors. Similarly, this is the point which is close to the hyperplane, and similarly this is the another point close to hyperplane, this is the another point close to hyperplane. So these are the support vectors. So on either side we have to consider the closest data points that lie, they are data points that lie closest to the hyperplane, which are used to define the hyperplane. So only because of the support vector we are able to, that is, define this hyperplane. It is a decision boundary, or you can say that it is a straight line. So the next topic is types of SVM. We have two types of SVM. One is linear and another is non-linear. Linear SVM, it is used when the given data is linearly separable. That is, if a data set can be classified into two classes with the help of a single straight line. For example, we have the plus symbols here, minus symbols here. Just by using a single straight line, we are able to classify, we are able to separate the data points. Then it is a linear SVM. In non-linear SVM, it is used when the given data is not linearly separable. So that is, if the data set can't be classified with the help of using single straight line. For example, you consider this diagram, this graph, in which you have all this plus surrounded by this minus. The symbol minus, it is surrounded, but inside we have this plus. It cannot be that is separated with the help of any straight line. If you draw any straight line, you cannot separate the plus from minus. So this being the case, it is a non-linearity. To solve this problem, we need to add one more dimension. So we have this x-axis and the y-axis. So add one more axis, one more dimension, that is z. So z can be calculated with the help of kernels. For example, z is equal to x square plus y square. There are different types of formula available, different kernels available. So here we are applying this formula, z is equal to x square plus y square. Just apply this formula on all the points, all the data points. As a result, we will have a graph like this, in which we can see that all the plus are separated from minus with the help of generating this 3D plane. Okay, so this is the axis, that is z axis. So already we had this x and y axis. This is a non-linear data. The problem can be solved with the help of introducing one more axis, that is z. So with the help of this, the plus symbols are separated from the minus with the help of this hyperplane. I hope you understood the concept. So in this video, I explain what is SVM and what is hyperplane, what is the significance of margin, and what is meant by the support vectors, different types of SVM, linear and non-linear. If it is a non-linear problem, how to solve that with the help of introducing the one more axis with the help of the kernel. Thank you. Keep watching.